So tertiary alcohols can form the chromate ester but cannot eliminate because they have no hydrogen on the alcohol carbon. So what you can see here, you can see that instead you don't see a hydrogen here, unlike your primary 1 degree alcohol or a 2 degree alcohol where you actually have your RCH2 or RC double bond O hydrogen. Carbon will always have hydrogen. So if you remember in one of these steps, if you remember in one of the steps like this one, we will, in the last step will always be the elimination of hydrogen to form your double bond. So we eliminate your hydrogen by forming hydronium ion H3O plus, you get your HO3 kanin plus, and the electrons between carbon and hydrogen will go to carbon oxygen to form a double bond. And then, of course, this one will be eliminated. The electrons coming from oxygen will actually be given to chromium in the process. You get this one. Okay, so there will always be hydrogen in this process. So this is an aldehyde. This is from an aldehyde in the oxidation process. For kanipod, this is a 2-degree alcohol, 2-degree alcohol. And the other one, you have a 1 degree. So there's always hydrogen bonded to carbon, but in the tertiary alcohol, you don't see a hydrogen. So there is no means of eliminating your hydrogen para ang kaning last step, will form a carbon double bond O. Carbon double bond O. Even sa imong aldehyde here, you also eliminate this one to form your carbon double bond O, and the electrons again for the final step will go to chromium. To have this one. So hydrogen will be eliminated in the process. You see this. But in tertiary alcohol, there is no way that hydrogen can be, that we don't see a hydrogen here. So instead, what we actually get are chromate esters. So as always, there is an electron on oxygen. There is an electron from the oxygen, and being a nucleophile, an electron-rich an atom, it can always attack on the positive center. So what you actually see, what we actually get is a chromate ester in the process. Pag form mo niya one of the oxygen, you get actually your OH, remember? OH. Pag form mo ng bond ng OH, you get a protonated OH. And then once you get your protonate OH, you actually eliminate the water in the process, and instead you get duha ka CR double bond O. This one will be converted to double bond here, and this one will be eliminated once this one is protonated with H plus, and it will be removed as water, as a living group, remember? And then in the process, you get a chromate ester. So in the end, dili gihapon nato siya ma-oxidize. So tertiary alcohols can form chromate esters, but we don't have an oxidation process here because there is no hydrogen. So there is a chemical test for primary, in general, inyo mabalaan for an oxidation can have a primary 1 degree and a 2 degree alcohol. To an primary, you can have an oxidation to secondary alcohol. From a 1 degree alcohol can be oxidized to aldehyde. You can further oxidize that one to a ketone. But if you want to stop at an aldehyde lang, you use a pyridinium chlorochromate reaction, PCC. Now, if you want to stop at that stage, the secondary alcohol can be oxidized taman kang ketone. Okay, so primary can have your primary to aldehyde to carboxylic acid, or primary to aldehyde lang using your PCC, but tertiary alcohol again with the oxidation process. So therefore, there is a chemical test for primary and secondary alcohols. We call that one as a chromium use actually chromium oxide in acid has a clear orange color, but when it is being reduced, you can actually see a green color. So here you can see on the oxidation state, this kind of reaction, you have an alcohol, RSH2OH, or a secondary alcohol. You have your RSH2CHOHR R here in the presence of chromium oxide and in aqueous sulfuric acid. So here chromium oxide actually is orange, clear orange. And yeah, wala mo ka-test. Naka-test mo, ayan, naka-test mo, di ba? Sa inyong laboratory. Test for alcohols. Tama ba? Naka-test mo, di ba? Test for alcohols. Yes or no? Sa inyong bang section? Yes, sa inyong section, naka-test mo. No, so you can actually have your test for alcohols using your chromium oxide and sulfuric acid. And what happens is that you get your chromium 3+ an oxidation product. Your oxidation products, you get your C double bond O, an aldehyde, or you can have your ketone, that will be your oxidation product. But what you get actually in the process is the change in color from an orange to a green. No? So what you see is you have your chromium 3+, it's actually greenish in color. So this one has an oxidation state chromium 3+ is the oxidation state of 3+, so a chromium oxide would have an oxidation of +6. So from +6, ma-reduce siya to +3. And chromium with 3+ actually is a green color. And that will be an indicator. Usually this is used sa kanang mga alcohol, sa kanang test for breath test, no? If we want to know if the alcohol is toxic with alcohol, if the person rather is toxic with alcohol while driving, so they use this kind of test. No? There's a change in color, you just have to breathe on some material, and there's a orange to red rather, and then you can say that there is the presence of alcohol from a person's breath. This kind of reaction is actually used for that. So this is a chemical test for primary and secondary alcohol. And the spectroscopic evidence for alcohols, alcohol OH, of course, we have already known this spectroscopic evidence for alcohols. We have learned this in FTIR spectra. No, for alcohol, you have actually an OH spectra absorptions in around 3,200 to 3,600 cm-. And we didn't have NMR. No, but if in case in the future, no, there's an NMR signal there, and the protons you can have between, anyway, we haven't discussed NMR, so never mind. It's just for now our indicator. If we do spectroscopic analysis for alcohols, you can just rely on the FTIR, and for the spectra, having this one. Hopefully in your next organic chemistry course, you will be talking about NMR. So there's actually what we call as organometallic compounds, compounds that contain carbon metal bonds. So why we are talking about this one? Some reactions actually, in particular for alcohol, would sometimes use organometallic compounds. Organometallic compounds, from the word organo, can have carbon atoms, metallic compounds with a metal atom. So carbon compounds and metal compounds, call that one as organometallic compounds. You can see a carbon metal kind of bond. So for example, carbon metal bonds vary widely in character from mostly covalent to mostly ionic depending on the metal. So when I say primarily covalent, no, pag you can see, depending on the metal, like the electrons between carbon and metal are shared between these two kinds of atom. Now they have different properties. Like this one is metal. Now, when they are equally shared, usually most likely equally shared, you have primarily covalent kind of bond between carbon and metal. when there is a part where there is a certain, the carbon atom will bear a partial negative charge and metal will bear a partial positive charge, then you call this one as partially ionic, right? But when the electrons would really belong to your carbon atom and the metal will be depleted with electrons, that's in such a way that it will bear positive charge and carbon will bear a negative charge, just like your carbon and ion. No? This kind of carbon metal bond is primarily ionic. Usually you can see this one when our metal is sodium plus or potassium plus. No? Like for example, you have your carbon and ion, it will always be paired with either sodium plus or potassium plus. And when one of the carbon atoms is carbon will bear the partial negative charge between carbon and metal. It's usually carbon that will bear the partial negative charge and metal will bear the partial positive charge. So usually the metal here is magnesium or lithium. But for primarily covalent, usually our metal here will be lead, tin, mercury, or tellurium here. So the greater the ionic character of the bond, the more reactive is your compound. So for example, here, if you have your carbon and ion, of course, you've learned that carbon and ion is a very reactive species. It's actually a nucleophile. We have actually used carbon and ion in one of the reactions. I think it was in the substitution reactions earlier. You have here, it's very reactive. So the greater the ionic character of the bond, the more reactive the compound. And organopotassium compounds react explosively with water and burst into flame when exposed to air. And that is one reason why usually the organometallic compounds has to be dealt using organic solvents, because usually in water they are very, very reactive. In fact, organopotassium compounds in water, they will actually simply burst into flame and expose to air. It reacts with water. So in the preparation of organometallic compounds, the usual one is the lithium. We usually use lithium with organic compounds. So you have the organolithium compounds. In the organolithium compounds, you can actually prepare that one with alkyl halide in the presence of a lithium metal in an ether solvent. So again, when we are dealing with organometallic compounds, metal, and then you have the organic compound, pure metal like, not ion hang metal, like elemental metal, lithium with zero formal charge, zero charge, example. So you have to deal with this one in organic solvent, like here, diethyl ether and lithium here, actually get your organolithium compound here. So an alkyl group and lithium. So alkyl, of course, expect your lithium to be positively charged and alkyl will be negatively charged. The order of reactivity for halides is Ri, Br, RCl, and Rf seldom used. So why is that? No, the iodine actually is more polarizable, okay? And you expect this one to be more reactive with lithium once you have your R halide here. And 2 moles of your lithium, you actually get your R lithium alkyl halide here. And you get your lithium halide as your side product. So one of the organometallic compound that is usually used in reactions are the Grignard reagents. So Grignard reagents are actually prepared by the reaction of organic halides with magnesium turnings. Magnesium, you know magnesium turnings? I don't know if you have already used this one in general chemistry. Katong mura siyang strips na magnesium metal. So it's not a salt, it's not in solution, it's not aqueous, it's not Mg2+, but Mg cubed, no. It's still a metal. Remember, metal, any metal which is malleable, which is like solid. Okay, so you have the Grignard reagents. It's actually prepared with magnesium and organic halides. So how is that prepared? So Rx, organic halides, your alkyl halides, and you have your magnesium metal in the presence of a solvent, usually diethyl ether, and you actually get your RMgX. So this is your Grignard reagent. So sometimes your Grignard reagent is an aromatic. Kasi ng aromatic, the one that I have shown earlier, katong murag benzene ring, katong 6-membered ring with an alternating double single bond. No? It's an aromatic. And then you have your halide attached to your aromatic ring. And magnesium is also a type of a Grignard reagent. So you have your aromatic MgX. So whenever you have your MgX and your alkyl group attached to your magnesium, it's actually a Grignard reagent. So what's ang RMGX? It's actually a complex, no? For your magnesium, alkyl halides, it's negatively charged, bonded to your magnesium, magnesium, okay, and your X, your magnesium, it's negatively charged, okay, you have your MgX, and surrounding this Grignard reagent actually is your diethyl ether. You can have your electrons bonded to your Mg complexing. No, and ether solvent is used because it forms a complex with the Grignard reagents, stabilizing your Grignard reagent here. Stabilizing for further reaction, to prevent further reaction. So how do we prepare? Usually, if you have seen in the reactions, usually we use an alkyl halide and your Mg, magnesium ion, magnesium metal, magnesium turnings, the presence of diethyl ether rather, at an elevated temperature, you get your CH3MgI here. So you have your C6HBr. This is a phenyl ring. It's like a benzene 6-membered ring, but one of the carbon is substituted with Br. And magnesium, you get your C6H5MgBr. This is phenyl magnesium bromide. What is phenyl? Phenyl is just like a benzene ring minus the hydrogen. We call that one phenyl instead of benzene. Benzene is the whole molecule with the hydrogen C6H6, but phenyl is minus isa ka hydrogen. You call it phenyl. So phenyl magnesium bromide here, methyl magnesium bromide from CH3. The reaction of Grignard reagents with carbonyl compounds actually can produce to form an alcohol. So palitan na naman sa itong reaction sa alcohol. Earlier, we simply used oxidizing agents or reducing agents rather from a carbonyl compounds paingon tong alcohol. But we can actually also prepare alcohol from our Grignard reagents. So there is a nucleophilic attack of Grignard reagents at carbonyl carbon is the most important reaction of Grignard reagents. So reactions of Grignard reagents with aldehydes and ketones yields new carbon bond and an alcohol. So again, unsa may source na to? Again, we know that for carbonyl carbon, oxygen is partially negative, carbon is partially positive. So asa may mo attack ani nila? Naray duha ka mo attack no sa inyong Grignard reagent RMGX. R is an any alkyl group bonded to Mg. Magnesium is positively charged, so you can expect your R to be negatively charged with the electrons in it. So again, there are two kinds of for partially ionic, no, whether your metal is magnesium or lithium, carbon will be partially negative, no, so it somewhat bears the bond between carbon and metal. Carbon will bear most of the electron density between them. Kani sa ionic is that carbon will own all the electrons. Here, primarily covalent shared sila, but in the partially ionic, carbon will bear the partial negative charge, and of course, most of the electron density will be directed towards no carbon. So if you have here your RMGX, so you have your R here, which is of course comprised of carbon, okay, with an R, any number of carbon here, branch or unbranched here, will bear the partial negative charge. So here you have a carbon that's partially negative charge, and this will become our source of nucleophile. It can actually attack your carbonyl carbon, which is partially positive. So again, when you look at the reaction, your first thing that you will always have to bear in mind, unsay properties sa imuhang atoms, no? Pag makaana mong ay oxygen, okay, partially negative. Tapad siya kang carbon, this carbon is partially positive. And then magnesium, it's a metal. Of course, you expect this one to be partially positive, any metal, you expect that one to be positive. Kato akong gigan ka ganina na induce lang to si chromium, no? Induce you to be partially positive, positive to si chromium ka ganina. And here you have your magnesium partially positive, no? And of course, the electrons is buried more by the alkyl or your halide. But between the alkyl and your halide, you get more the electron density from here. So what happened is that the nucleophile, this will be your source of nucleophile, the R group from your alkyl halide, or alkyl halide, from your Grignard reagent, no? The R or the carbon with an electron will attack this carbonyl carbon to form R C bond, okay? And of course, you have bond here, and the electrons, once it attack here, the electrons gikan kang carbon and oxygen, mabalhin kang oxygen, forming an O minus. Once you have your O minus, can be protonated, can have further step to be protonated to get your alcohol here. So here is a reaction of getting our alcohol gikan sa atong using our Grignard reagent. And what you can see here is actually, if you want to get an alcohol with a higher number of carbon atoms, if you remember, once you have your reducing agents, no, the same number of carbon lang to, di ba? Whenever pili number sa imong carbon atom from an aldehyde, imong alcohol will also get the same number. But you can see here in this kind of reaction, you have your already a ketone, for instance, or an aldehyde or an ester, no? Carbonyl carbon. You have already specified number of carbon here. But if you have your Grignard reagent, napaka another source of your carbon. So imagine once you form an alkyl halide and carbon bond, increasing imong number of carbon. And of course, you get your alcohol. So this kind of reaction actually is a new source of pathway if you want to increase on the number of carbons or desired structure of your alcohol, no, from the original one. And of course, the side product is MgX. So let's see if you have we have the mechanism here. So what is the mechanism? We have already stated the fact that oxygen is partially negative for a carbonyl compound and carbon is partially positive. In the Grignard reagent, now you have your MgX, your magnesium will be partially positive, and your R, your alkyl group, will be partially negative. Again, so what is your alkyl group? R is simply your carbon, any carbon atom with an R group, whatever side chains you have. So you have here your carbon with R. Okay, so R here is your carbon atom with an electron, of course, it's partially negative. So the bond between R and Mg belongs more to your R, okay? And you see more of the electron density kanto kang carbon. So you have your partially negative being partially negative with an electron with it. Now that will become our source of nucleophile, as I mentioned earlier. It can attack your carbonyl carbon here, which is partially positive. So once it forms a bond, what will happen is that, of course, you have carbon here, 1, 2, 3, 4 na. So kung mag-form of bond of 5. So of course, si carbon and oxygen, the pi bond will be converted to an unshared electron kang oxygen here. Okay, so oxygen will bear now a negative charge. You have 2, 4, 6 from 4. From 0 charge, name mo siyang negative charge sa oxygen. So we will, and of course, you have your Mg2x minus here. Okay, so the total charge is 0. You have your halo magnesium oxide. So what happens once you have here? Of course, you would like to protonate this one, no, and eliminate the charge. Of course, this is ionic and still bonded to your magnesium here. This is a ionic kind of bond, no, to magnesium. So it's an organic compound bonded to magnesium. Since here is full positive to an X minus here, form a bond here. So we protonate this one. We use this one as our base, lowest base, to find a proton. So we need a hydronium ion for our source of hydrogen to form your RCOH. Get here. So once you form a bond here, see water, you will recover your water, and the hydrogen oxygen bond will reverted back to an unshared electron. So you get your water and you get your alcohol here. So what happened to your magnesium Grignard reagent? So Mg2x, actually you get your magnesium halide. It's a salt, no? And yes, so it's very easy. It's a very easy kind of reaction. And this kind of reaction, what is the general reagent? One is, of course, in an organic solvent and protonation reaction. You use this RMG in ether and RMGX. The second step will be your protonation reaction. Okay, so that's another balik. Alcohols from Grignard reagents, aldehydes and ketones. So that was for alcohol. That was for carbonyl compound to produce your alcohol, no? The higher number of carbon atoms. So aldehydes and ketones react with Grignard reagents to different classes of alcohols depending on the starting carbonyl compounds. So depending on your carbonyl compounds, you can actually get a 1-degree alcohol, you can get a 2-degree alcohol, or a 3-degree alcohol. And another interesting fact, of course, you have learned already, is that if you start your carbonyl compound with only a specific number of carbon, you can actually increase on the number of carbon atoms. So for example, your R here is duha ka carbon, you can actually increase your number of carbons here from isa lang from your carbonyl compound to tulo na if you have an alkyl here which is made up of 2 carbons. Okay, but your case of whether it's a 1-degree, 2-degree, or 3-degree, depending kung unsa yung gigamit ng carbonyl compound. If you are using an aldehyde, like a formaldehyde, you get a 1-degree alcohol. If you are using a higher aldehyde, this one is a formaldehyde, you can get your 1-degree alcohol with a 1 carbon atom higher than your R. If you are using a ketone or an aldehyde with a higher number of R prime, you can get a 2-degree alcohol. So ano 2-degree man, you get your R here, your R. So what happens is, of course, your R alkyl group is your source of your electrons that will be our nucleophile. Again, it's a nucleophilic attack on your carbonyl carbon to attack your carbon here. What happens when it attacks? You use the electrons taken from R, you get your RCO, and your oxygen will become negatively charged. It become, again, tulo ka unshared electrons with a negative charge. So it's a negatively charged, fully ionic. It can form a bond with magnesium in ionic form. Okay, and we acidify this one. This will become our source of electrons again to find a proton, our base, like electrons finding a proton to form your OH here. And you get your 2-degree alcohol. If you start with a ketone, what happens is we actually get a 3-degree alcohol. So again, the same process, no? Instead of hydrogen, you get an R here, another R. Again, that will be our source of alkyl group, will be our source of nucleophile or electrons. To form a bond, so use this electron, RC bond, and pareha rin na RRR, sidyl bond. Of course, mawala ng sidyl bond, nga naman, anubra naman ta, of course, diba, it will be converted to unshared electrons. You get an oxygen that's negatively charged. It's negatively charged, it should be paired with positive magnesium, but we need to acidify. So you can use H3O+, okay, or you can use your source of proton, which is NH4+. NH4, it's acidic also. So you can use that one as a source of proton. It's less acidic than this one, but it still can be used as a source of proton. Your source of proton is from hydrogen NH4+ here. So you abstract the hydrogen here to get your OH. And you actually get your ammonia plus NH3 and yes, MgX. Okay, so your 1-degree, 2-degree, 3-degree, depende na again kung unsa ang inyong carbonyl compounds. And similar to your aldehydes, ketones, and formaldehyde, no, esters can also react to form our react with Grignard reagent. But in this case, you have first have an unstable product, and then you finally get your ketone, and then first you have your another mole of that, you get your salt of an alcohol, and then a 3-degree alcohol with acidification. So how does it happen? So same process gihapon, no? Balik, your R will be your source of electrons. This is your nucleophile because it's paired to magnesium. This is partially negative. So if there's more of the electrons, gikan na nilang duha. So it can attack the positive carbonyl carbon. Once it's attacked, the electrons here, pi bond, maadto kang oxygen, you see, you get your O dot dot dot. So it's ionic actually here. Okay. And what happens is that instead of acidification, para mahimo siyang OH kani, kopya raman nato, di ba? Instead nga mahimo be acidified that one. To get your OH, what happened is that kani, mabalik ni siya, we will utilize this unshared electron, no? Para to form a pseudo bond O kani, and we eliminate the OR. Gikan aning sa ester. So we're able to eliminate the OR in the process. In the process, what we actually get is a ketone, R coming from the original ester and the other R coming from your Grignard reagent. So we get a ketone. So this is your actually initial product once you have your ester with your Grignard reagent. Once you have your ketone, you can further react that one with another mole of your Grignard reagent. No? So the same rig hapon, magnesium is positively charged and R is partially negative. It bears with it all the electrons coming from kaning bond, RMG bond. So this will be our source of nucleophile or source of electron. We will attack, this will attract rather the carbonyl carbon. So you get your copy rin na to, di ba? RCC. Kani. So we'll form an RC bond, a new bond. Once it forms a bond, duha na ka red, duha na ka R. Once it forms a bond, what happened is that kani maadto kang oxygen. And you get an O dot dot dot. Tulo ni siya ka unshared electron and negatively charged. Okay, and we'll acidify this further. Okay, this will be our source of electrons or a base, no, to find a proton, then you get your OH. So NH4 plus can be our source of hydrogen, H plus, not hydride, ha. H plus, which means a proton depleted with electrons. So you get your electrons coming from oxygen will be used as our source to form a bond with hydrogen. You get your OH. So you get your alcohol. So in the process, what you get actually is a 3-degree alcohol. So parihara siya ani, a ketone. Anong parihara mo siya sa ketone? Your initial product actually is a ketone. It's actually a ketone or initial product. In the process, we actually eliminate the OR sa atong ester. Okay? So the reaction of ketone and ester, pari-parihara siya. In the process, we eliminate the OR sa atong ester. So katong pag-eliminate sa OR, we actually get another form of alcohol for that. So what else? So in general, you have your reaction with formaldehyde for any, and this is for any alkyl, for any Grignard reagent. No? Like here, you have your phenyl magnesium bromide, balik-balik mani. You actually get your kani. This will be your source of nucleophile to get this one, to attack this one. So kung ma-stuck gani mo, because maramog ma-shock sa kadaghan sa reagent, no, you always have to identify on the properties of your substance. Kinsay positive, kinsay negative, kinsay source sa inyong electrons, and you can always follow. Like, huy, unsa man ni siya, sim MgBr, and unsa niyang source. Of course, magnesium is positively charged. Expect this one to be your source of electrons. Okay? So what happened? Kani siya will be our source of electrons, si carbon with an electrons, ikan ani nilang nga bond. We will attack this carbon. Pag-attack na to niya, we actually get your kani and this carbon bond, and we actually have your pag-form of bond. This is converted to an O minus, kani O minus, naradi ay O minus with an 3 unshared electrons, and we acidify further with H3O plus. So O minus, taparan lang yung mag-MgBr, okay, and acidifying that further, you actually get your alcohol. So here is your benzyl alcohol. So 1 carbon with your like benzene ring. So di mo matingala ha, this one is actually your benzyl alcohol. It's not, akong benzene lang, minus na siya, this is the ring. But with 1 carbon and OH is actually called benzyl alcohol. So for example, here you have 2 carbons and you have this one. You can expect that 1, 2, 3. Duha din. 1, 2, 3, 4 is actually get your 4 carbon. So this will attack this one, this carbonyl carbon. And of course, since sana siya are, you expect a secondary alcohol. Okay, this one, you attack this one, this will be converted to O minus. And with CH3 here, okay, and O here, hydrogen and O bond. Okay, and acidify that one, OMGBr, acidify this one, the O, that to unshared electron, that will be our source of electron to abstract the proton here, so you get your OH, and you get your alcohol, and this is a 2-degree alcohol. And reaction with ketone, balik-balik. So this is our source. 1, 2, 3, 4, 5, 6, right? So dili na ta kani sumpay nato dinhi kani convert siya kung OH and then nakay duha kani. Simple. This will be your final product. But of course, there's a step for that. There is acidification process. Before you proceed with your alcohol, you still first get your OMGBr. Okay, before your OH. So OMGBr, this is ionic. You have 300 electrons with a negative charge. So further acidify that when you get this one. Reaction with esters. Remember the reaction with ester, it's a similar actually to the reaction of a ketone. Okay, so may eliminate ni si kani. So kana, react this one. So payan na to, kani mo convert ng OH. Tick, 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 tick. Okay, kani. So kani, 1, 2, 3, 4, and OH. You get this one, and here you have CH3 here. Okay, and then you have your another mole of that. Another mole, you get first you get your ketone rather. You have your you have first your ketone, kani. So kani. You get your 1, 2 na manakasabot. You have your 1, 2, kani, ma-eliminate ni siya in the process. So 1, 2, 3, 3, 4. Kani ang ma-eliminate in the process. Because once you form this, attack this one, you get your OMGBr, the double bond will be converted to unshared electrons. So minus, you get this one. And in the process here, you eliminate this, you get your O, you eliminate this one, you get your CH3. Okay, so you get your ketone, arsenic. Matanggal ni siya, mabalik siya to double bond in kanisiya, you get your OR. So it's a negatively charged actually. What happens here, pag form ni mo ani, no, matanggal ni siya, we will form a double bond kani. Pag form ni mag-double bond, matanggal ni siya. So you actually get your ethoxide, but your ethoxide can be paired with kani balik. Okay, so kani siya. I mean, si ethoxide, mo form siya with MGBr, kay you get a double bond, single bond of CH3. So once you get your ketone, mo ni ang giingon, this is now your source of your your new source of your single bond O. Okay, so that's the reason mas ma-increase pa gid imong number of carbon here. So you have your 1, 2, 3, 4, 4 now, 1, 2, 3, 4, plus another mole of your Grignard reagent. This one, attack this one, okay, form a double bond, form an CO dot 300 electrons and paired with MGBr. Of course, you have this and you have this. And you have your NH4Cl, you can actually acidify this one further to an OH. You have this. So, pila tanan? You have 1, 2, 3, 4, 5, 6 is another mole of this one. So 6 tanan ka carbons. And this is actually a tertiary alcohol. Once you start with an ester, you get a tertiary alcohol. ever you have an ester and ketone, like this, the ketone. Once you have your ketone, get a 3-degree alcohol. But once you have an ester, you first get your ketone before form of 3-degree alcohol.